So and then next, this is the last video for today class. We do the example here. This is the complete amplifier circuit. So we have here the source here, and then we have the load connected to the amplifier circuit. Okay, so the first step is you need to remove the capacitor. So the capacitor is, we have three capacitors, C1, C2 and C3. So C1, if you remove it, nothing will happen. But C3 and C4, C1 and C2 and C3, if you remove the C2 and C3, by removing it means that you make it an open circuit. So there will be no connection between the RL and amplifier, as well as the source with the amplifier. So you can ignore this part. So what will happen is you will have the bias circuit only. So this is the this is 2K, 2K, this is 2K. You have your RG1, this is 50K, this is 50K. And then this is minus 10 volt, this is plus 12 volt. Okay, so you have this bias circuit. Okay, so you need to analyze the simplified circuit. Okay, if you see the 2 kilo here, this 2 kilo and 2 kilo is in parallel, so you can combine it and make it one resistor. So 2 parallel with 2K parallel with 2K is actually equal to 1K. Okay, so let's redraw it again. This is 1K, this is 2K, and then we have here, this is 50K, 50K. Okay. So you have this equation. The first step is the next step is to identify the transfer characteristic. Okay, transfer characteristic is ID over K VGS minus VGS TH square. So it's given that the VGS TH is 2 volt and K is 1 milliampere. So you get here ID is equal to 1 milli VGS minus 2 square. So this is your first equation. The second step, the next step is the KVL at input loop. So this is your KVL. This is your KVL at the input loop. So when you do the KVL at the input loop, you will have this is plus IG 50K plus 50K, and then plus VGS plus ID 1K, and then you have this minus 10 is equal to 0. So here this term is equal to 0 because gate current is 0. So you got here VGS plus ID 1K minus 10 is equal to 0. So this is your second equation. Okay, you have the first equation, you have the second equation. Okay, for this example, we do the mathematical solution only. For the mathematical solution, from the second equation, you can define the ID is equal to 10 minus VGS over 1K. This is your 2A. So insert the 2A into 1, so you get this one is 10 minus VGS 1K is equal to 1 milli VGS minus 2 square. So this is 10 minus VGS. And then you got this VGS square plus 4 minus 4 VGS. So and then lastly you will get the equation VGS minus 3 VGS minus 6 equal to 0. So the solution for this is the solution here is we have two solutions. The first solution is 4.37 volt. Second solution is minus 1.3 volt. So you should choose the one that bigger than the threshold voltage. So the VGSQ is equal to 4.37 volt. Okay. And then IDQ can be calculated from the equation 2a. IDQ is 10 minus 4.37 over 1k. This is equal to 5.63 milliampere. This is the answer. Okay, let's say you want to calculate the VDSQ. So what is VDSQ? VDSQ is the voltage across the drain and the source. Okay, so to do that, you need to do the KVL. So the KVL is so this is minus 2 volt, and then this is plus ID 2k, and then plus VDSQ, and then plus ID 1k, and then this is minus 10 equal to 0. So you know ID is 5.63. So actually you can solve this equation. You should get the minus 22, and then plus ID is 5.63 milli times 2k plus 1k is 3k plus VDSQ equal to 0. So VDSQ is equal to, so the term 5.63 multiplied by 3 is equal to 16.89. So this is 22 minus 16.89. So this is equal to 5.11 volt. So this is the solution for VDSQ.